So, thank you for sticking with us for Virtual Azure Community Day. I have Willem here, Willem Meints, who is AI expert. I can tell you, he's machine learning AI expert at InfoSupport, even author of a book around machine learning, creating your own machine learning algorithms. So you're pretty hardcore if it comes to AI and machine learning, right?
Yeah, I spend a lot of my time in machine learning these days. So 2 years ago, I got asked by a publisher to write a book about deep learning. The Microsoft Cognitive Toolkit, which was a thing back then.
Ah, yeah.
It's still available for people to read, but I have to be honest that these days CNTK is no longer maintained, so you can still download it if you want. But most of the people have moved on to things like PyTorch to build their deep learning models. So that's what I use also for my day-to-day work. So normally I think about half of my time helping projects get up to speed with new technology, and those mainly focus on data and AI. So I do know how to build a data lake, but I also spend a lot of time explaining how to build classification models or fraud detection stuff, that sort of thing. And the other half of my time I spend building internal communities at InfoSupport, but also externally through the global AI community. That's also what I do.
Yeah, because you're also a part of global AI community.
Yeah, for quite some time now.
Yeah.
So back when Henk started, shortly after that I joined and started helping in the Netherlands specifically to set up a meetup nights. And last year he asked me to join the community in full and as a board member to help out organizing events, for example the Global AI Virtual in October. So that's pretty cool actually.
Yeah, I understood that for the global AI community virtual in October that you're still looking for speakers?
Yeah, that's correct. Yeah, we're still actively looking for people who want to share their story about their project, for example, stuff that's inspirational. So it doesn't have to be technical per se. You can also talk about how to improve the way we use AI as a society. But if you have a deep dive thing around deep learning or maybe reinforcement learning even, that's fine too. We focus on beginners as well as experts in the global AI community.
So everybody, doesn't matter how experienced you are,
no, not at all.
Can join that event. That's cool.
Yeah.
Nice. Yeah.
Yeah, we want to be open to anyone from any background. So even if your internet connectivity is not the best in the world, we don't mind. We'll work around that and make sure that your story gets told to the community and people can learn from what you've done in your work. Yeah.
Okay, cool. Well, can you tell me a bit about your session, which you're giving in a few seconds?
Yeah, so one of the things that's pretty hard in machine learning is that the algorithms are pure math, so they only understand numbers, but somehow it turns out that some models are fair to people and other models are pretty unfair to groups of people. For example, you can have a model that hands out credit cards that pulls ahead women instead of giving equal chance to men to get a credit card. I've also looked into models that do things like deciding whether a person should be monitored extra after that person comes out of jail. These models can become pretty unfair to people, so that's a problem. And what Microsoft has done this year is they built a package called Fairlearn that allows me to measure how fair my model is towards groups of people. And it also helps me mitigate some of those issues that come with unfair behavior. So that's what I'm going to show today. We're going to talk a little bit about how to train a model and how it becomes unfair, and then we'll focus on measuring and improving fairness in the models.
Wow, making a model which detects if your model is unfair?
Yeah.
That's mighty
It's almost full inception,
yeah,
you could say that, yeah.
Okay, cool.
Yeah, it's a pretty cool library.
Looking forward to your talk. If you head over there, I have just one little thing to address, and that's if you like events like this, and if you want to learn more around Azure or other developer topics, then you can subscribe to our newsletter, Microsoft.source. If you go to aka.ms/Microsoft.source, you can subscribe there. And we will once a month email you with an overview of events, cool stuff to do. For instance, create your own board game on Azure. So we'll put the link in the chat, and well, just subscribe if you're interested in all that. Now let's head over to Willem about Fairlearn. Go ahead.
Thank you very much. So yeah, as I mentioned, my talk is about Fairlearn, the secret sauce to teaching your models to play fair. It's a Python library that you can download. It's a fully open source, so if you find an issue in the library, you can certainly try to fix that yourself, or at least report it and check the source code. Sometimes that helps. So for those who don't know me, I'm Willem Meints. I'm a Microsoft AI MVP for the 5th time this year, actually. I work as a technology advocate at InfoSupport, which is, for InfoSupport, is not a typical role. Mostly I spend my days helping other teams get started with new stuff like AI, data platforms, that sort of thing. If you're interested in talking to me, if you have any questions, please ask them in the chat, or you can reach me afterwards on Twitter or on LinkedIn if you are so inclined, or send me an email. That works too. So my talk is actually split up in 3 parts. So the first part is about what is model fairness. In order to understand what Fairlearn provides to you, we have to first understand what is an unfair model, and how can I see that, whether it's unfair. Then once we know what unfair models are and what model fairness is as a concept, we can start talking about measuring model fairness using Fairlearn. I will show you a demo where we take a model that we've trained, and we're going to see whether that model is fair to all groups of users that are going to use that model. And finally, once we know, is the model fair or unfair, we can start talking about how to improve model fairness using Fairlearn, which is another part that is included in the library. So let's dive right in. So there's a new credit card company that I thought up of on a Saturday afternoon when it was raining and didn't have time to play with my kids or do other work. Bits and Dollars. Bits and Dollars is a special credit card company in the sense that they use machine learning for everything around giving out credit cards. They only do credit cards, and they do credit cards like this. A customer comes in and they have to provide their payment history and some other data. And Bits and Dollars uses a machine learning model to decide whether that person is going to get a credit card or not. If that person is likely not to pay the credit card bill next month, according to this model, they're not going to hand out a credit card to them. If the person, on the other hand, is going to pay for the bill, and the model predicts that, we're going to hand out a credit card. It's a special kind of company. It's rather weird. Whether this is a good idea to build or not, I don't know. But at least it's something. And Bits and Dollars has a tagline, not sure if you're going to get the credit, because we're using AI. So Bits and Dollars has found a problem in their model that in many cases, women had a higher chance of getting a credit card than men. It was very likely that the model would predict that a woman was going to pay for the credit card bill than a man would. And that's interesting. And they don't know why that happens, but at least it's something that triggered them to start thinking about model fairness. So what is model fairness then? Model fairness is this concept where we say, well, a model treats individuals equally, or groups of individuals equally. So there's 2 ways in which you can look at model fairness. The first one is fairness towards individuals. And it works like this. So if I have someone from Amsterdam of a particular age and a particular education level, payment history, that sort of thing, and we have another person coming from another location, but otherwise it's pretty much the same person to the model should give the same outcome for those 2 people. If that doesn't happen, we have unfair behavior towards individuals. The other type of fairness that you can look at when you talk about model fairness is fairness towards groups. And this is slightly different in the sense that you could have people of older age and people of younger age, and they could be treated differently by the same model, despite the fact that there shouldn't be a difference. The same happens for bits and dollars in this case. The bits and dollars notice that men are treated differently by the model than women, and that can be a problem. Whether that's a problem for your specific case, that depends on the context that you work in. So in the case of bits and dollars, they want to make sure that they hand the equal amount of credit cards to both men and women. There shouldn't be a difference between the two groups. They've decided upon this after careful deliberation between board members, technical people, the people that know about this sort of stuff. So we're going to focus on group fairness in this case, and the reason for that is that Fairlearn, the package that I'm going to show you today, is actually geared towards this group fairness concept. It doesn't know about fairness towards individuals. This stuff is coming in the future, I don't know when, but they are working on that, and they are doing active research in model fairness towards individuals, but it's not out there yet. Fairlearn is a very new package, it's 0.4, the version number, which also means that it's still in full development, it's in preview, and you have to be aware of that. So let's take a look at what Fairlearn can do for you in the case of group fairness. So before I dive into actually measuring my model fairness, we have to take a look at training the model first. Why? Well, I think it's good to understand, even if you are not familiar with machine learning, what's actually happening underneath the covers of a machine learning model. So when we train a machine learning model, and in this case we're training a supervised model, I'm trying to build a model that connects a certain sample of data to an expected outcome. If you go back to basics, what happens is that we train the model to make a connection between certain properties of a person that's going to request a credit card towards the fact that the person is going to pay for the credit card bill or not. And this relationship is based on data that we provide. So what could happen is that this model is going to train, actually, that female equals the credit card bill is paid, and male, the credit card bill is not being paid. Obviously, that's not the only property it looks at, but it looks at a lot more properties. So let me show you what happens. So what I've done, I've written a bunch of Jupyter notebooks. Jupyter notebooks is a way of building Python code and mix in documentation so you can explain what you're doing. So in this case, it's pretty cool because I can explain to you in text form what's happening. And at the same time, it's interactive, I can execute code. So what I can do is I can say, select this cell and press Control Enter and it will execute a cell. So I've run all this code ahead of time just to save a few minutes. What happens here is that we're loading a data set from disk using the pandas library, which is a well-known library for data science applications. It allows me to read CSV files, Excel files, tab delimited files, that sort of files, and make a table out of that. And we can take a look at the table, what it looks like. So I can say df.head, and it will give me the first 5 rows of this data set that I'm using for this model. So what you see here is a table that has a number of columns in them. I'm not going to show you every column, but just to give you a sense of what properties we're looking at when we're trying to determine whether we should give someone a credit card or not. So it has an ID, which is normal in a database. We're not going to use that for our machine learning model. It's unique, it's not useful for machine learning. We're also going to look at the limit of the credit card. In this case, it's expressed in a decimal number ranging from +1 to -1. But that's not the only property. We're also looking at gender of the person, male versus female. We're also looking at education level, marriage, age. As you can see, these properties are pretty sensitive to being able to distinguish groups in my dataset when I try to train my model. Other than that, there's also a bunch of properties that tell me about how much someone paid for their credit card and how late they were with their credit card payments. And that's essential information to train my model because that will connect certain payment behavior to the fact that the person is going to pay for their next credit card bill or not. But I've included these properties at the beginning here, gender, education, and marriage, on purpose, just to show you how a model becomes unfair. Apparently, there's a connection between the gender of the person and the fact that the person is not going to pay for the credit card bill. So what I can do, I can take this data set and I can extract a bunch of properties from this data set that I want to use for training. I can also extract from this data set the column of values that I want to predict. So in this case, it's the default payment next month column that contains a 1 for a person is not going to pay their credit cards. The person is going to default, in essence. And it will contain a 0 in the case that the person is going to pay for the credit card bill. The person is not going to default in that case. When I have these input properties and the expected outcome, I can both put them both into my machine learning algorithm, and I can ask the computer, hey, can you find a connection between these properties and the fact that a person is going to pay for their credit card bill? Can you find a pattern in my data? That's essentially what we're trying to do. And for that purpose, I've used a random forest classifier, which is a specific type of machine learning model that allows me to generate hundreds of decision trees that account for every single value for every property that I have given it. And it will try to detect a pattern that connects the input, the payment history of the person, and the gender and the age and the education level, to the fact that the person is going to pay or not pay for the credit card bill. So once I have this classifier, I can train this, and this will take a few seconds to run on my machine. It's pretty fast. And what will happen is this model is now capable of predicting whether a person is going to default or not. Is going not pay for the credit card bill, or they are going to pay for the credit card bill. As a good data scientist, I have to make sure that this works. So what I've done at the beginning is I've split my data set in two parts, a training set and a validation set. The validation set is never shown to the model. Why not? Remember, we took the samples and the expected outcome to learn a pattern. And a computer is rather, it likes to cheat in that sense. It's going to remember the samples that it has seen. It has a tendency to do that. And I want to make sure that I'm measuring the performance correctly by using data that the model hasn't seen before. So it doesn't remember the samples, it tries to detect the pattern instead. So there's different ways of doing this. The easiest one is running the score method on my model, which is standard in scikit-learn, the library that I'm using to do machine learning. And the score method is going to give me back a measure called accuracy. It's going to say to me, well, this is the percentage of samples that I've predicted correctly. So in this case, 84% of my samples were predicted correctly. There's another way of using a receiver operator curve. I'm not going to into much detail on this one, but ideally you want this blue line to go from this corner on the left to the right, and then vertically from the top left to the bottom left in the graph. That's ideal. Diagonally, however, it's totally random. As you can see, this model is not perfect. It's somewhere in between perfect and random. Which you would expect from a model that has an 84% accuracy level. So once I've trained my model, I can save it on disk, and that's the point where we can start looking at model fairness. So let's go over there. In my other notebook, I've pulled up my model again from disk, and this model I can use now for prediction still. That works. But instead of doing predictions directly, I'm going to use this model to measure fairness. So for this, I need a testing data set, which is again not used for training, but it's only used for testing. And then I'm going to fire up the Fairlearn dashboard. So the Fairlearn package that you can install from the Python package manager, like so. So you can say, well, I want to install Fairlearn. I can say pull up PowerShell or your favorite shell for that matter, and I can type in pip install Fairlearn. And this will download Fairlearn from the internet to your computer, install it in your current Python installation, and that's how you can get started with this library. I'm not going to execute the command because I already have Fairlearn on my machine, but you will have to do this the first time you're going to use Fairlearn. So once I have Fairlearn installed, I can then pull from the widget module in the Fairlearn package, the Fairlearn dashboard widget. And this is a special kind of component that interacts directly with my Jupyter notebook. So it renders HTML to the display after it has calculated the fairness of my model. So I can import this. And then what I have to do is I have to fire up this Fairlearn dashboard. I have to create one and feed it a couple of things. So the first thing I have to do is I have to feed it a set of sensitive features that I want to check the model for. In this case, I'm going to limit myself to gender. The reason for that is that I know that this is a problem. This is what Bits and Dollars told me when they approached me. Hey, this is broken. Somehow female users are getting way more credit cards than men, and that's strange because it should be equal. Aside from these sensitive features, I also have to give a set of labels to the dashboard so it can display those features correctly. In this case, I'm saying, I'm giving it a column name, but I can do a slightly less, a friendlier way of saying this. So the first thing then what it then needs is a ground truth. So what it will do is it will use these expected outcomes to measure the performance of the model for different groups of users that are using my model. In this case, I have the column default payments next month in my dataset, which is the ground truth. So this is what is expected from the model, and I can feed that in. And finally, the fourth thing that I have to provide is the predicted outcomes for the model. So what I can do to obtain these is I can say model.predict over here, and I can feed it the columns, the feature columns from my dataset that I've read from disk. And out comes a set of predictions in this case. So I'm not predicting one sample, I'm predicting a couple of hundred in this case. So when I call the Fairlearn dashboard, when I create it, I get back in my Jupyter notebook a Fairlearn dashboard. And the Fairlearn dashboard in this case helps me to get started measuring model fairness. And it will do that in 2 steps. So the first step is you have to select a set of one sensitive feature that you want to check for. In this case, I have one feature, which is gender, so I will select that next. And then the second step is I will have to look at a performance metric. And I will show you why that is in a minute. So let's get started. So the first step is I have to select a feature. I only have one feature in my case, so I'm selecting gender, and it has 2 values. The first one is male, value 1, and the second one is value 2 for female. This is what happens in this data set. You might have other values that you want to check for. So once I've selected this sensitive feature, I can then look at the metric that I want to use for measuring performance in my model. Why do I need to select this? The Fairlearn dashboard is actually going to look at the difference in performance between one group and the other, in this case between male users and female users. So I need to feed it somehow what I'm looking at, what I want to check out. In my case, I'm going to look at accuracy. So when I click next, it will generate 2 graphs for me. The first one is disparity in performance, and the second one is disparity in predictions. Let's go over each of one of them and take a look at what happens actually in these graphs. Not everyone will be familiar with this one, so I will take you over this step by step. So this first chart will display the difference in performance between male and female users. Depending, of course, if you're looking at male and female users, if you have a different metric and a different attribute, it will be different for you. First, I will display the overall performance. In this case, based on the testing set, the performance is 81% accuracy, which means 81% of the samples are predicted correctly. And then it will say there's a 6.77% difference in performance between male and female users. Could be good, could be bad. We don't know. But there is a difference, and that's striking. We can see that this model is unfair. It should actually be close to 0, this disparity value. So when we scroll down a little bit in this graph, we can see that there's 2 bars being plotted. The first one is for male users and the second one is for female users. And we can again see the accuracy for each different group. In this case, the model is fairly good for male users. And that's a good thing. 86% of the cases it predicted correctly. So that means if you hand out credit cards to people, 86% of those customers are likely to pay back their credit card bill. For female users, it's a lot lower. And you could say, well, this is a business risk. We should give out less credit card to female users, but that's actually not fair. That's not how it's supposed to work. We're handing out far more credit cards to female users because of these second values that you see over here. In blue, you can see the over-prediction of the model, which means that we are predicting 1 where we should have predicted 0 with the model. So we're predicting that someone is a defaulter rather than a fair paying customer in 3.9% of the cases for male users and 3.9% for the female users. Looking at the orange bar for the under prediction, it's 17% for female users, which means that in many cases we will say, well, we should have predicted that you were a defaulter and we're not going to give you a credit card. But instead we said, it's no problem, we can give you a credit card. So the underprediction here shows you that it's far more likely for a female user to get a credit card, which might be a problem. Again, depending on the context that you're working on and how you want to approach this. So the second chart is actually a different way of looking at the same issue. The disparity in predictions only looks at the outcome of the value 1. So in this case, when we predict a defaulter, in what percent of the cases that we predicted a defaulter, it's a male user, and in what percentage of the cases that we predicted a defaulter, it's a female user. In 11% of the cases, it's a male user that we're predicting. In 20% of the cases, it's a female user. So this shows you that in the case of defaulters, it's far more likely that a female user is a defaulter. So these are a lot of numbers to crunch, I can imagine. So it will take some time to get used to reading these kind of graphs, but the aim here is to look at these numbers at the top first and see what's my overall performance and what's the difference between groups, and then decide what to do with these different groups that you see here in orange and blue displayed for under prediction, over prediction. You actually want to make sure that the model has the same behavior for both groups in this case. So that's what we're going to look at next. So in this next bit, we're going to talk about improving model fairness. So in the previous section of my slides, I've shown you how to use Fairlearn to detect unfairness, and we've seen that bits and dollars has a problem here. In this next bit, we're going to try and improve this situation. Fairlearn is a machine learning library. It won't be perfect in the end, and you will see this in a minute, but it's good to keep that in mind when we try and solve fairness problems. It's not a black and white situation, sadly. So there's actually 2 ways in which you can fix unfair behavior in your model. The first one is equalized odds, and the second one is demographic parity. So let me explain a little bit of what both of these algorithms do for you. The first one, equalized odds, will say, well, I'm going to modify the model in such a way that both groups have the same chance of getting a specific outcome, being that 1, the person is a defaulter, or 0, the person is not a defaulter. It doesn't actually look at the actual outcome. It will only say, well, I'm going to equalize the odds. It's going to level the playing field in that sense. The other one, demographic parity, has a slightly different approach to fixing unfair behavior in the model. In this case, we're going to make sure that the output of the model is not dependent on a sensitive attribute. And it's important to understand what happens. So if I were to include gender directly into my training data set as an attribute to detect a pattern on, it's likely to pick that up and make a difference between male and female users. So the logical choice is to remove this attribute from my training set and say, well, I'm not going to train on gender because obviously that's a bad choice. And that's always a good thing to do. But the challenge here is that sometimes you're indirectly depending on a sensitive attribute. So what can happen is you're dependent on income of a customer. That seems to me like an attribute that's fairly normal. But in reality, female customers might be earning less money than male customers. This is what happens in the real world. So indirectly, income is actually telling you something about the gender of the person. It's not true in all cases. It's true in a certain part of the cases. But I think in a lot of cases. So we call these proxy attributes, and you might still have a problem there with unfair behavior because you're indirectly actually predicting a sensitive attribute. So this demographic parity actually allows you to remove the effect of a certain sensitive attribute on the outcome, no matter the fact that this attribute is part of your training set or not. It knows, it even detects indirect relationships here. So that's a lot of talk, a lot of theoretically important stuff. But let's take a look at another piece of code and see what happens when we try to improve our model. So in this last notebook that's in my sample, I'm again loading up my model, and we're going to try and improve this. We'll first load up the model in the dataset. We'll then use the threshold optimizer, which is a component in Fairlearn that allows you to fix or at least improve the fairness of your model. That's what we're going to use to improve the situation for bits and dollars. And finally, I will show you a cool trick where you can compare actually your original model with the improved one. So you can judge for yourself, is the model actually getting better because of what I did here? So this first bit of the notebook is actually loading up the model, loading up the data sets. If you're interested in all the details, I suggest you go up to my GitHub account and take a look there. I'm not going to explain it in great detail here. The important bit here is actually the threshold optimizer. So what does the threshold optimizer do exactly? Well, it takes your original model and it's going to modify it in such a way that it becomes more fair by adding another layer of machine learning on top of your existing model. And it's important to understand this, what this means. So I explained at the beginning of my talk that machine learning is all about trying to find a pattern in your data and explaining the outcome to the user. So we're trying to make a connection between some values that we serve as input and an expected outcome. And this is the pattern that we find. The threshold optimizer is going to modify this pattern slightly so it is more fair. But it's not going to be perfect because it's all based on statistics and probability. There's a chance that it becomes better, but that's not true fact, actually. So what I can do here is I can import the threshold optimizer from the post-processing package in Fairlearn. So it's actually a post-processing step. It adds stuff to your existing model. So you don't have to retrain the model. That's actually a good thing in some cases. This threshold optimizer works for regular machine learning models like decision trees, regression algorithms, binary classifiers, that sort of model. But it also works for deep learning. And as many of you will probably know, fair learning is a very intensive way of building a machine learning model. It takes a lot of compute cycles to train a model. It can take days to produce a deep learning model. And you simply don't want to redo this training to make it more fair if you can get away with that. So in this case, that's a good thing from the threshold optimizer. It's a cool band-aid, I would say. So once I have imported my threshold optimizer, I can create a new instance of that and store it in my optimizer variable. And this threshold optimizer requires me to put in my original model that I've loaded from disk in this case. And I have to tell it which of the algorithms that I've just shown we're going to use. So I can choose here between equalized odds to level the playing field, or demographic parity, where I'm going to say, well, I know that income is an indirect pointer to gender. Please remove this connection. Make sure that the pattern doesn't match that. Once I've done that, I can call the method fit on the optimizer to train it so it can equalize the odds or improve, disconnect the input from the output where it matches a sensitive attribute. And this fit method requires me to put in my training samples and the expected outcome, and a set of sensitive features that I want to look at to optimize the model in terms of fairness. This final bit seems like a bit weird. At least to me, it didn't make sense at first, because I thought, well, why am I going to have to tell my model that there's a sensitive feature in there? You can detect that yourself if you want. But right now, that's not the case in the Fairlearn library. They are working on that, but it's for a future release. That they are going to remove this attribute, actually, and you can just pull in the training samples and the expected outcome, and that will give you a good result. For people that have done machine learning before in Python, this fit method seems really, really similar to what we've done before in training the model. And I can show you. Let me see where it is. It's here, see? It's exactly the same API for using Fairlearn as it is for machine learning models, so it's not very hard to do so. But keep in mind, it's a machine learning model. So once we've trained this new optimizer model, we can use that instead of the original model, and that will produce a more fair outcome based on the fact that it disconnected gender from the expected outcome in the pattern matching. And I can show you that this works. So again, I can pull in the Fairlearn dashboard, and I can say, well, fire it up and see, show me, is it going to work? Again, I'm selecting the gender as the sensitive feature, and I'm selecting accuracy as the metric. And in this case, I'm a little bit unlucky because the difference in performance is a little bit worse than it was before. See? When I measured it in my original model, it was 6.77%. Now it's 7.37. 37. Also, notice that the overall performance has gotten a lot lower. And that's one of the trade-offs that you're going to run into. If you try to make your model more fair, the overall performance is going to suffer a little bit from that. This might not be a big issue, but it's important to keep in mind. However, when I look at the other parts of this graph, I can see that the model has become a lot better because right here, there was a massive underprediction for female customers. And it's not so big anymore after I've applied my threshold optimizer. So that's a good thing, actually. It's become more fair, although the overall performance has gotten worse. When I look at the second chart in this screen, you can see that there's also a difference here in behavior from the normal model and the optimized model. So previously I had 9.5 difference in performance when predicting a defaulter, and now it's only 3.61%, so that's a lot less. So overall, you could say that this model has become somewhat more fair towards my users, at the cost of overall performance, of course. And that's one of the things that I think is important to keep in mind from using Fairlearn. It's fairly compact in API, so with a couple of lines of code you can get this working. And it does some very advanced stuff. But because of that, you have to spend a lot of time thinking about what is unfairness for my company? What does that mean in my context? What's actually the purpose of my model? And is it justified to include certain sensitive attributes? Can I select on that? And also, if you are going to improve fairness in your model, you have to be aware that the overall performance is going to drop slightly. This may or may not be a problem. If you value fairness, I think it's a worthwhile trade-off to think about, but maybe balance it out a little bit. Of course, if you're allowed to use certain sensitive features and that's okay with the users as well, then yeah, you've got a different choice to make. So that's what I have to show to you today. If you have any questions, you can leave them in the chat. We can talk about them. And otherwise, contact me on Twitter if you want to learn more. I should note, if you want to try this out yourself, I've got some code over on my GitHub account that you can download and try it out yourself. It has a Docker container inside it in the repository, so you don't have to install Python actually. You can use Visual Studio Code remote containers, and it will spin up a Docker container for you, install Python in there, and do all the stuff that you need. So that's it.
Yeah, thank you very much, Willem, for your session. If you can hop over, then I'm gonna pain our producer because he will have to probably turn the camera a little bit to make sure you're in the
yes.
view. But I like to stress it a little bit, so just so we can relax and and Henk has all the problems. Okay, awesome. So, well, that's a very huge stop it. Okay, so hey, yes. So I think Sjoukje had a question for you.
Yeah, I have a question. We also asked this question to Eva after her previous session. But do you have some tips for people to get started with this topic, like me, for instance, because I don't know anything about this?
Yeah, so I get asked this a lot by different people from different backgrounds. I think the easiest way is to start learning Python, first of all. There's a cool website, learnpython.org, that has a great tutorial. You can get started in 20 minutes, and that's pretty amazing to me. And then there's, I believe, a lot of stuff on Microsoft Learn also about AI in general. So they explain how to use stuff like scikit-learn in Python to build machine learning models.
Yeah.
And it's really low level, so they start with small models, with small data sets, so you can get a real sense of what's going on and get this pattern in your head where things revolve around probabilities and what that is actually.
Okay.
Which is an important concept to understand for machine learning. And if you feel comfortable with that, I would then go into deep learning, and not before that, because deep learning is one of those topics that people find really interesting because we can do some very powerful stuff with that, but it's also very, very complicated. I had a hard time learning it at first, at least.
Okay. Yeah, I can imagine. It looks very, very difficult. Yeah. Right.
And, because I think that's fair enough to take like baby steps. Learning each part of the process before you start diving into deep learning, of course. But I think it should also be important to take into account like a bias which you might like inject somewhere. So do you have any tips on that to learn just more about the ethics side of AI?
Yeah, so there's two approaches to that. There's a whole philosophical side to it. So you can talk in very theoretical scenarios about what is a fairness in AI and how do I handle that. But that's the problem with all ethical issues, that When you talk about it in theory, it can be very, very hard to handle. But again, I would suggest actually take a look at the Fairlearn website. They have a great guide explaining what fairness is and how to actually make educated choices about that. And when you bring it back to basic choices, it's actually not that hard to make the good choices for your model. Yeah.
Okay, is Fairlearn heavily used in AI?
No, not at the moment. It's growing fast. It's only been around for a couple of months, so it's pretty new still. Yeah. Okay. But more and more people are discovering that ethics and fairness and all these problems are important to them. Especially data scientists that have been building models for a little bit. They discover, hey, it's a thing. I can introduce bias into my models, and I don't want to do that actually. But it's very hard to solve this problem by hand, so Fairlearn is a welcome contribution to this field. Yeah. And there's more stuff coming. So Eva showed the interpret text, which is all about explainers, which is another aspect that I think is important to actually learn as a aspiring machine learning engineer or data scientist. It helps you understand this black box. It's a black box. We're putting in data and we're putting in an expectation, and it somehow finds a pattern in my data that explains this connection. What does this pattern look like, and how can I influence that? Well, explainers help you pull this black box apart and get inside and get the real nasty bits out and discover that sometimes it's a really stupid reason why you get a certain outcome. I've seen some pretty spectacular things around image recognition, where I had a bunch of pictures with green grass and blue sky and then a sheep in the middle, and I would replace a photo of the sheep with one of a white dog, and it would say, yeah, that's a sheep. And why was it a sheep? Well, not because it saw a white thing in the middle. Blue sky, green ground. That was the problem.
Yeah. Because that was actually the same.
Yeah.
Yeah.
Machine learning is stupid as a brick, actually, if you ask me.
Yeah. So it's extra, like, you never want to make an assumption, of course, but assuming that a model recognizes something eventually in a picture, that's like a no-go.
Yeah, it's quite impossible to look at every single sample that you've used for training, but in general speaking, you're right. Yeah, it's pretty dangerous to make any assumptions about that. I would actually use an explainer anytime I train a model, just to verify for myself what's actually happening on the inside. So that's pretty cool. Yeah.
So you can trust the model a bit more. Yeah.
Yeah, only a tiny bit more.
Yeah.
It's pretty new. And we were talking about machine learning before. So the mechanical bits are go do these courses on Microsoft Learn or any other website. But actually, I would encourage people to give it a try. Build a model, see what it does, and improve that model, and keep on improving that over and over again. There's no way your model is going to be perfect the first time, and there's no way to actually humanly predict what's going to happen. So you have to train this model, give it a shot, run it a few times, then you will discover, oh, there's a problem, and try to fix the problem, and then you will start to learn how it actually works. It's learn by doing, and actually later on, once you are an expert, it's still learn by doing. That's the funny bit about machine learning. Yeah.
And in your experience, like when you learn, like you create this model and use the data set, and then you have like a result. If you iterate like each time, which is obviously a good thing because it will get better over time, you will get better, the model will be better. But how do you keep an audit trail of this?
Yeah, so that's one of the problems. I work a lot with machine learning engineers and data scientists that send me zip files over the mail with the model and some log file that maybe contains some metrics. That's actually not a way to go about this. So there's a solution for that. Microsoft offers Azure Machine Learning Studio, Azure Machine Learning Service, I should say, these days. And this tool, which is cloud-based, allows you to run experiments on your machine or in the cloud and track metrics from your training run and collect those over time. And that will give you a way of comparing previous versions of your model with the new version, and also tells you exactly what the performance is of this particular model that you deploy to production. Because
Okay.
that's the other thing that Azure Machine Learning solves for you. It allows you to run experiments where you track the data from your model and the metrics and all the stuff. It allows you to collect data and store that safely so you can version your data sets. Because each time you change the data set, you add new samples or you remove them, you have to retrain the model. And things will be different. So you want to track data to model to actually deployment to production, which is the third thing that Azure Machine Learning Service does for you. It allows you to deploy a model to production. And it will tag it with the exact commit hash from Git that for the source code that you use to train the model. So you get a full audit trail from start to finish that you can use to prove to your customer or authorities or auditors that you've done the right thing and there's nothing wrong. And also, for a data scientist, it's important to keep track of this because you can always go back. If you mess up, you can always go back one version to a model that does work, and that's a great thing.
Yeah. Awesome.
Wow, there's a lot of things to, keep on learning. There was a question in the chat actually around book tips for Python. Well, I think you already.
That's a tough one. There's so many books about.
Now you have to pick one.
I don't know the exact title, but there's Machine Learning with Python that covers pandas, scikit-learn, the general theory behind machine learning. That's a good one. I can actually link it in the live chat afterwards.
Yeah. Great.
So we'll get back to that then in the chat. Awesome.
Cool.
Thank you very much.
Yeah,
Awesome
welcome.
session. Yeah. So our next session will be Albert-Jan Schot, who's going to talk about running static sites in Azure.
Yes, and thank you. And stay here. Don't go away, unless it's to one of the other tracks, of course. Keep it up. Anytime, just reach out in the chat if you have a question around the various topics. I noticed a lot of speakers still hanging out in the chat and ready to answer any question, even though their session has long been gone. So, thank you for your interaction and stay here and see you after the break.